Hey guys, welcome back to AutoTechNick, and we're back on the jet boat today. Now in our last video I talked about setting the intake and getting that locked into place permanently where we wanted it. Well, now that that's locked into place, I got the pump installed. It's time to get the engine placed into the boat. We're going to install a rail kit today, so I'm going to spend some time talking about engine placement, how to get that rail kit installed, and most importantly we're going to be talking about drive shaft and U-joint angles. So before we talk about the rail kit that we're going to be installing in the boat today, I wanted to take a second and just show you what was previously installed in the boat. Pretty typical setup for the era. You got your cast aluminum front and rear engine plates with the feet that mount to it. A little unusual on my setup where it had these steel plates bolted to either side of the stringer and the feet bolted through them also. And it had those steel drive shaft loop that someone made that bolted to the suction housing of the pump. Nothing wrong with this setup. Perfectly fine. I could still reuse it, but I made the decision to put in a rail kit rather than reuse this kit. The added benefit is I'm not reinstalling all those steel plates or the drive shaft loop, so I'm saving about 55 to 60 pounds on this setup in comparison to the rail kit. I will tell you that I did weigh all the components of the rail kit in comparison of the feet and the two cast housings on this setup, and it only came out to about a 10-pound difference, which I think is pretty much not a difference at all. Now the reason why I chose to move away from this setup and go to a rail kit simply is, well, honestly I was on the fence. I couldn't really decide. There's nothing wrong with that setup. I could have reused it, and I was kind of pondering, can I save the expense, save a little money, reuse that kit, maybe down the road put a rail kit in. And the defining or the deciding decision that made me decide to do a rail kit ultimately is, for obvious reasons, I'm going to be very selective and cautious on how many and where I drill holes in my stringers after all this work I've done to the bilge. So I wasn't going to put that old kit back in and then down the road put in a rail kit and have all these extra holes. If I'm drilling holes in all this work that I did, I'm going to do it right. The rail kit's going in from the get-go. That way, it's just going to have, ultimately in the end, the look that I wanted. Now as for the rail kit, I chose to go with a kit from Lightning Performance Marine, and you can see I went all out, got the nice polished kit. I got the flywheel cover, drive shaft, the rails, the outer stringer braces, our engine mounts, and the mounting blocks. Now one thing I do really like about this kit is the mounting blocks. They are full billet, they are machined, and if you look carefully, they're not a true 90 degrees. They actually have a 4-degree angle machined into them, which is going to help us out a little bit later when we get everything set up. I also took the opportunity to replace my old H-bar drive shaft here with the newer 1310 U-joint, which requires this adapter, but in combination with this adapter, this new U-joint, it will come to the same overall length of this setup, so that way I don't have to worry about any of the positioning with the pump or the engine. And obviously the rail kit comes with the alternator mounts and all of your hardware. Alright, so you can see that I took a couple minutes to get everything protected. I used some more of this plastic that I have protecting the outside of the boat, placed that down in the bilge, taped up my stringers, taped up both the front and rear engine plate, and I'm just trying to keep everything as nice as I can as I get it mocked up. Now I do want to mention that when you order these engine plates from Lightning Marine, they will talk to you and ask exactly what width you want them made to. They will make them any width that you have to fit your stringers. When I ordered my kit, I ordered them at 26 inches apart, and I did that intentionally, and I even tried to plan ahead. When I put my stringers in, I actually put them in at 26 1/4 apart inside dimensions, and I was trying to give myself a bit of a buffer for all the tabbing and gel coat. Good intentions. I missed it by maybe 1/8 of an inch, so you can see that I'm just a little bit narrower and these plates won't slide down in between the stringers, which is not that big of a deal. The reason why I say it's not that big of a deal is because I don't necessarily need this engine perfectly centered in between the stringers. Is what I really need is I need this engine, or specifically the crankshaft, perfectly in line with the shaft of the pump. That means that these engine plates might be shifted a bit off to the left or right in between the stringers. So I don't just want to go cut equal amounts off each side of these and drop them in, because ultimately I may have to shift it to one side or the other, and they'll be uneven. It won't look that good. So I'm going to go ahead, I'm going to get this front plate put on the engine. I need to get the engine swung into the boat so that way I can get the engine centered up and we'll know where and how much we need to trim off these plates. I do have a tip for you when you're doing all this mock-up, and when you're positioning the engine, you're going to want to be sure that your PTO or your drive shaft's not bottomed out in the pump, which mine is right now. You're going to want it pulled out about 1/8 of an inch. Now if you look and see, I have 2 marks on there, and it's currently sitting in on the first mark, not the deepest mark. That's because I went ahead and calculated that exact 1/8 of an inch and used that stack of washers there, using a little bit of butyl tape to hold them on. So if I were to pull those washers off, that's when this will slide all the way down to that one deepest mark. And is what this will basically let me do is now I can slide the engine in, push all the way back, and I don't have to worry about it. I don't have to worry about the engine creeping back on me and making sure that it's positioned where it wants to be. It's one less thing to worry about, one less dimension to worry about as I'm getting all this mocked up. When I'm done, I'll just go ahead and pop those washers out and I'm set. It's worth noting that this yoke bottoms out on the outside race of the bearing, not the input shaft bottoming out in the yoke. That's why my stack of washers is well in excess of 1/8 of an inch, but it only gives me an 1/8 of an inch standoff here with the yoke. Here's what we're working with. I was able to steal those steel plates that used to be in the boat, threw them across the stringers, and I have the engine plate sitting on them. I have just a little bit of weight still on the engine hoist, but it's allowing me just to slide the engine left to right as needed. I wasn't even able to get the drive shaft hooked up because the engine's so high, so I just have it lined up the best I could. You can see up here I have a laser line, and that's running down the spline of the pump. If you can see it blinking there, it goes through the grease zerk. Tried to center it up on the drive shaft, and I'm hitting it up here on the spline of the block in that hole. My chain set up here is blocking the view from the rest of the way up on the front of the engine, so I just had to kind of do it the best I could. But I have it pretty centered, I think. It's good enough for what we're doing right now, and as you can see, it's biased quite a bit to the starboard side, so I'm going to have to trim those sides and bring you guys around over here. And these sides should be good. I shouldn't have to trim those. So this is kind of a good example of what I was talking about earlier, that it's really not a big deal that I have to trim this. It's going to allow it to sit how I want, but I didn't want to just jump right to it and trim both sides. So to get my marks, I just took the old carpenter square here and actually held it flat on the bottom and then up on the inside, and then just ran a mark up onto the tape. Same thing onto the front. So I'm going to go ahead, pop this back out, pop the plates off, then I'm going to jump over to the bandsaw, get them cut. I'm only worried about the rough cut right now. I will fine tune this a little bit better once it gets all the way down and into the stringers, and I can have it sitting on the rails itself. But for now, I think it's good enough. I'm comfortable with where it's at, so I'm going to go ahead and just nip off a little bit on each side here, get it back in, get it leveled up, and see if we hit it or not. We got the plates cut, and you can see that it now fits in between the stringers, and it's sitting down approximately where it needs to be. I was fortunate where I got the front plate cut on the first shot, although I missed the rear one just by like 1/8 of an inch, so I just had to pop it back off, took it to the disc sander, and just knocked a little off of it, and allowed it all to go slide down. So I got the drive shaft slid into the pump, and everything's roughly in place. Like I said, I wasn't really chasing the absolute perfect centering of it right now because all my rigging's in the way, and I want the engine sitting on the rails, and then I'll fine tune it left to right, but it's probably within 1/8 of an inch right now. It's really stinking close. Now that we have the engine in place, it's time to start discussing angles in between the pump, the drive shaft, the engine, and the boat. So I'm going to take you guys over my whiteboard, and let's talk about that in a little bit more detail. Where we're going to place or mount this engine is all dictated basically by the drive shaft angles. So we shimmed the shaft and the yoke so that way the engine is as far back as it needs to be. That dimension's already determined. So now the height of the engine is going to be dictated by ultimately by the angles of the U-joints. Now in order to get all this set and established, it's really best practice and a lot easier to make sure that your boat is level. I didn't really discuss any of that in this video because I went into that in great lengths in the last video where I set the pump intake. So if you want to check that out, go ahead and take a peek. That video definitely runs through it and how I got it level, where I measured on both axes. For the sake of this video, it is leveled. We're going to continue talking about it being leveled. So using the same diagram as last time, you can see that I have the boat leveled, the bottom of the keel. So we have our bow coming up, it rises down, we have our keel where the water interfaces, that's level or set at 0 degrees. The intake is mounted at the same level or 0 degrees to the bottom of the hole, again referencing the bottom. Since I have a 4-degree intake on my boat, that means that the suction mounting surface of my intake is now set at 4 degrees. So now when we're setting the engine, This is our engine, my crankshaft. We have our pump shaft. Our pump shaft is at the same 4 degrees of the mounting flange of the intake. So I'm going to set my crankshaft at the matching 4 degrees. Now, U-joint angle is critical in a jet boat, even more important than it is in a car in my opinion. And that's because the U-joints directly push on the crankshaft in a jet boat. In a car, you have a transmission in between and it can kind of buffer some of that. What I'm going to achieve, or what I'm trying to achieve, is I want a 1.5 degree angle in my U-joints. So I want a minimum angle in there, so that way they're not perfectly in line and parallel. I want a little bit of angle so that way there's no vibration, the needles are turning, but I don't want any excessive angles because that's where it starts to push forward on your crankshaft and actually pushes the crankshaft into the mating surface of your thrust bearing, and it will wipe it clean very quickly. So in order to calculate that angle, if we set the engine at 4 degrees, the pump shaft at 4 degrees, and made those perfectly parallel, our H bar or our flat bar on our U-joint or PTO would be at 4 degrees. If we did that, everything's perfectly in line and there would be no angle at all within those U-joints. So we don't want that. So what I'm actually going to do is you have to think that 4 degrees is our starting point, or neutral essentially, meaning everything's perfectly level. So we're going to pick the engine up just a little bit while maintaining that 4 degrees, and we're going to shoot for 5.5 degrees on the bar in between the two U-joints on the drive shaft, and that gives us a total drive shaft angle of 1.5 degrees. Now there's a lot of great information on Spicer's website where they talk about what degree you want, how to calculate the degrees, and they even give you RPM charts of what max degree you can have per RPM you spin. This is what I'm choosing for my setup, so now I'm going to take you over the boat and show you real quick. Now before I started any of this work, the first thing I did was actually re-level the boat, so it's exactly how I was talking about on the whiteboard, leveled out. Now you'll notice on our drive shaft on the flat, it's sitting at the 5.4 degrees, close enough to the 5.5 I was talking about. Since my boat is leveled and I have a 4 degree intake, I should see 4 degrees back here on the pump, 3.9, essentially 4. And if we go to the crankshaft, you can see that it's measuring 3.9, 3.94. So you can see that I have exactly what I drew out on the board. Now, what I did is I used this load leveler here to get the engine crankshaft set at 4 degrees. The pump, it's set at 4 degrees. And then I just took my angle gauge, set it on the PTO, and all I can do is just take my cherry picker and raise or lower the engine, and it maintains that 4 degree angle, and it changes that degree right there on that PTO. So you can see that the engine placement is really dictated off the pump placement and the U-joint angles. Now that I have the engine essentially where it needs to be, I have my plates fitting in between the stringers, the engine's at the correct angle, correct U-joint angles, it's centered side to side. I need to start looking and evaluating my rails and where they're going to go onto the stringers. But before we go and look at that, I'm going to have to jump back to the whiteboard. I got one more thing I want to run over with you guys. Because my particular rail kit came with these blocks that have the 4 degree back cut already engineered into them, that means that I need to go ahead and put my rails installed level into the boat. Now, if you rewind way back when I installed the stringers into the boat, I installed those at the same level or 0 degrees. So that means when I install my rail kit now, my rails are going to be installed at the same 0 degree. This will sit flat on it, and that back bevel is going to go ahead and give my engine and engine plates the 4 degree crankshaft degree that I'm looking for. So keep all this in mind when you're installing your rails. You want to make sure you maintain that level. That way you can use these blocks to maintain that 4 degrees. And really what we need to really watch out for is the height of the rails. That way we don't change our drive shaft angles. So I'm going to take you guys back to the boat and let's start scoping out where these rails are going to fit. Now that our engine placement is where we need to be, we can take a peek of where the rails are going to line up if they're sitting underneath the mounts. Now if you look on my setup, let's see if I can swing you down, they are very low when I set them directly underneath the engine mounts, almost to the bottom of the floor of the boat. There's maybe, wiggling my finger in there, oh I don't know, maybe ½ an inch down there. And although it worked just fine, I don't like the looks of that. I kind of prefer the rails to sit a little higher, so I have this other one over here on the outside I can kind of show you. I kind of prefer where they're sitting up there quite a bit higher, closer to the top of the stringer. And I can't just mount them there right now with the plates, because then that's going to raise up my engine too far, and it's going to put a radical angle on my drive shaft. So I need to make a choice. Do I go the easy way and mount the rails deep on the inside of the stringer, or do I raise them up real high like I had out here on the outside rail? If I do that, that means I'm going to have to trim my plates to get the engine to sit down on the rails deep enough to maintain the angles that I need. For those of you that have been watching this rebuild for a while, you know what I'm going to do. I'm going to pop the engine out. I'm going to mount the rails higher up on the stringer so they look the way I want them to, which means to get the engine back into the place it needs to be, I'm going to have to trim the bottom feet or the bottom part of these engine plates to get the engine lowered back down onto those rails to maintain all my angles. So it's going to be a fair bit more work and trimming, especially just sneaking up on it slowly at a time, but it's what I want. It seems that when faced with the decision, it seems if there's an easy way or a hard way, I naturally just dive right onto the hard way. So just going to embrace it, lean into it. I got to get the engine popped back out of here. I kind of have some freedom on my rails on where to position them. Also, one thing I didn't mention is since I have these boards up at the front of my bilge area, that I pretty much have to run my rails essentially butted up onto them. So I don't have to really worry about the placement fore and aft. I just need to make sure that they're level and at the height that I want on the stringer, and then the rest of the work is going to come into trimming these plates. Alright, so I was able to successfully drill all the holes in the stringers and mount these rails in. I can tell you that it wasn't really that pleasurable or fun drilling into all this work that I've invested back here. Naturally, I'm really worried or concerned that I got them done right, drilled in the right location the first time where I'd have to oblong them or re-drill it, and I was able to get that done. Now, I did take these rails and I actually used both of them to mark the holes for each side. So I'd actually use one on the outside, set it like so, and leave this back face flat up against the side of the stringer. The top is sitting on top of the stringer because I have such a rounded edge. I took just some extra metal stock that I had, and that gave me the space that I wanted for where the stringer, or where the rail was going to sit in relation to the height of the stringer. Then I just clamped the stringer on the inside in that little pocket there, and I'd mark the holes, and then I flipped it to the other side of the stringers, did the same thing. So I had holes marked on both sides. Then I just worked my way up with a really small drill bit and drilled a little bit on each side, each hole, until they finally met in the center, and then worked my way up to the hole that I needed for the bolts, and it worked out quite well for me. Now, before I go ahead and mount this other rail in, since the engine's out, it really gives me a good chance to show you what I was talking about earlier on the placements of these rails in relation to the stringer. So when I had the engine in with the plates uncut, I put a mark on the bottom side of those plates, which would indicate where the top side of these rails would go. So if I were to go ahead and install these rails where I would have to not cut my engine plates, they would be installed about there. So it's about 1.75 inches down below from where I wanted them. I could easily just go ahead, drill those holes, bolt them in, and not have to modify my engine plates and bolt or drill and bolt the blocks on right there and be, for the most part, done. I prefer my rails to sit much higher up. Just it matches and looks a lot better, in my opinion, to the top of the stringer. So I went ahead and placed the rails based purely on aesthetic. Now, once I set this block back in here, it's going to be entirely too high, and I'm going to have to cut the bottom of the engine plate so it can sit down and sit on these rails where I need to get those drive shaft angles that we needed. All right, here we are. The engine is sitting back in there. I have all the weight off the cherry picker, and once again, the drive shaft, I can't get it into the input shaft of the pump. There's just too much height in the engine, so almost like we took a couple steps backwards when we first started mocking everything up, but not really. It's all starting to kind of come together, and this is my own doing because I raised the rail height. But one thing I wanted to show you is now my crankshaft, you can see it's sitting at 3.9 degrees. I have all the weight off. So the reason why that all comes out is because this rail kit, as I mentioned, these blocks have the 4-degree back cut built into them. So the height of these plates, front to rear, when sitting on a level plane, put the crankshaft at a 4-degree angle, which matches my pump shaft angle. So that's very nice because, well, that's already set and we don't have to mess with it. And you can see that it's nice and leveled out side to side on the engine block. And also, these blocks that I talked about earlier, you can see that I set them down on the rail and they slide right up on the engine plate and everything ties in real nicely. So if I wasn't so picky and didn't raise the height of those rails on the stringers, I could have just drilled all those holes and I pretty much would have been set. But because I moved the height, is what I'm going to have to do is I'm going to have to go ahead and I'm going to have to cut sections out of these plates right here to get my engine lowered back down so I can get my drive shaft in and on and the angle set. So this is going to be a little bit tedious. I'm going to kind of take one decent sized chunk. I'll have to remeasure, but I think it was 1 3/4 inches total height difference. So I'll probably make my first cut at 1.5 inches, get the engine set in, remeasure my angles, and then I'm going to take small pieces and slowly refine it until I get that engine dropped down at the height I want. I'd rather sneak up on it than overshoot it and have to pick it back up. So all my cuts I'm going to do, they're going to be pretty crude, just 90-degree cuts right here. Once I have the engine set where I want, I can take the plates off and I can give all those cuts some shape and radius and make them look the way I want. Right now we're just trying to get it set and get angles in. So for me, it's going to be some measuring, cutting, filing, sanding, measuring, cutting, file, sanding, wash, rinse, repeat. I'll bring you guys back once I have this sitting where it needs to be. First rough trim is done. I took 1.5 inches off both the front and rear plates, and I'll bring you guys down. You can see I'm just doing a very minimal trim just so I can get everything set in here. I'll come back later and make this look nice. So equal amounts off front and rear, which maintained my 4-degree angle on the crankshaft. Now I view the 4 degrees here as my zero plane, just to make it a little easier. So when I'm talking about the angles on the PTO, I want 1.5 degrees for the U-joints. That means I need to add that 1.5 degrees to my 4-degree baseline, and that gives me 5.5 degrees. You can see that I've dropped my gauge down on here now, and I'm sitting at 10 degrees. So that means that I'm 4.5 degrees off, and I do know, since we did the measuring, that I guessed that I needed about 1 3/4 inches cut off the rails, and I cut 1.5 inches. I'm a little bit higher. So I need to go ahead and continue trimming the engine plates down so I can get the engine lowered down in the boat and get that drive shaft and U-joint angle at 5.5 degrees total. Sure, I can go ahead and pop these engine plates off. I can make small cuts, drop the engine back down, recheck my angles, and slowly work my way up to the height that the engine needs to be at to achieve my 5.5 degree angle here on the drive shaft. I'm at 10 degrees on the drive shaft. That means the engine is sitting higher than it needs to, causing an extra 4.5 degrees of angle in the drive shaft. That got me thinking, what if there's a bit of an easier way? What if I were to go ahead and shim this engine up to gain an extra 4.5 degrees on the drive shaft angle, and then I can go ahead and calculate or measure how high I had to shim the engine up, and that should theoretically tell me how much I'm going to have to go ahead and drop the engine down. Now, I didn't want to make my first cut at the 1 3/4 off these plates because I wanted to be sure, you know, go 80% of the way there to be sure that that cut and that method is getting me where I need to be and it's going to work. With the 1.5 inches cut off the plates, I'm confident that's what needs to be done, so I'll be a little bit more willing to get really close to that final dimension. So I just figure I'm going to go ahead and use some of this extra metal that we used to mock up some of the rails. I'll just go and lift this engine up just a little bit, just enough to stick these under the feet, and then we'll drop it back down, check our angles, and I'll keep making adjustments here until I get this engine at a total angle of probably 14.5 degrees. I'll make a measurement of how thick those shims are, and then that's what I'm going to target to cut off the rails, and then from that point I'll do my fine tuning. So I'm hoping that this works out like I think. I don't see why it won't. I'm going to get to it, and I'll bring you guys back once we have everything set. All right, we're getting real close to getting this dialed in exactly where I wanted it. Now, my idea was shimming the engine up and then making that measurement. Worked out great. It ended up being essentially 1/4 inch, which is very unsurprising because I initially measured 1 3/4 and I cut it 1.5 inches off. So I went ahead and made those cuts. Now, I will say that I did a little bit of filing mainly on this foot right back here on that plate to go ahead and take a little wobble out of the engine and bring the back end of the engine down a little bit. But now we can see that we have our 3.8. We've maintained essentially level on the engine, and we wound up with 5.251 degrees. So just a hair low with the engine overall, which is fine because I can go ahead and just lift that up just a little bit before I drill my holes to mount it to get it back to that exact 5.5 total degree that I'm looking for. But I didn't overshoot it too much. I only had to end up cutting those plates twice. So my initial cut and then my fine-tune cut, and then I just filed down 1 foot. So I consider that a success. So I have the engine sitting where I want in terms of angles. I have the 4-degree crankshaft angle on the crankshaft. I have the 4-degree pump shaft angle, and well, I'm 1 degree on the U-joint. I would like to bring that up to 1.5 degrees. But before we go ahead and drill the holes for our blocks and the rail and the mounting plates, I need to circle back and I want to make sure that this engine is centered as I had planned. Now that the engine's sitting exactly how I want on the rails, I can go ahead and pull. You can see I pulled all my chains off the engine to free up the valley, so that way I have an unobstructed view of my laser that I went ahead and, well, just mocked up on the cherry picker because it was convenient and it made it easy. So I'll go ahead and kill the shop lights in here so it's a little bit darker and you can see that laser line, and I'll show you what we're working with and what adjustments we need to make. With the lights off, we can see our laser line loud and clear. Just like the first time we ran the laser line on this boat, I have it centered up on the spline of the suction housing, my grease circ down inside there on the pump shaft, and that's my baseline running through the boat. I also verified that it lines up here on the transom and further forward, so I know that it's center on the boat. Then I'm making adjustments to the engine to make sure that my U-joints, that the laser lines center through those. And I'm actually using these holes that are drilled on the China wall here on the front and back of the engine, and also just through the cam valley to make sure that lines up center. And also in the front, it overhangs a little bit where I can see if the crankshaft's centered up. Now, initially when we put this engine in, we had to go ahead and move it over a little bit and trim our rails. And I have found that I was able to get that centered back up on the front hole, and initially I was off to the port side and I pulled the engine over a little bit, but back here on the rear I don't have enough adjustment on my engine plate. I don't know if you can see it back there, it's so dark, from where I initially cut those, and I'm just a hair off, and it's also hard to see when it's dark, but my U-joints have a little bit of a shift into them where the back of the engine's a little bit off to the port side. So what I'm going to need to do is pull this rear engine plate out, and I'm going to need to go ahead and cut along the side to give me more freedom to slide this engine back over, and hopefully that will get everything lined up. So we're not going to make any cuts or adjustments to the height of the engine right now. We're only doing it so I can kick the back of the engine over. I think I probably only need to do about 1/8 of an inch, and I'll have everything right where I want it. Alright guys, we are dialed. I got the engine set exactly to the angles I want. I got it centered, and I'm ready to start drilling some holes and get those blocks put in. Before we do that, I do want to show you that if you notice, I got my drive shaft angle back up 5.4, and I did that by just putting some business cards underneath the engine plates when I had the engine out. I initially started out putting 3 cards each under, and it was way too much. I had like 6 degrees of drive shaft angle, so I started pulling cards out just to get the height that I needed. It turned out 1 card under each leg got me exactly where I wanted to be. So if we come around and take this gauge off the drive shaft, you can see that it's very straight and parallel. There's no twist in this H bar, that the engine is centered to the pump shaft. We don't have any angle with the engine like that, so it's nice, true, and straight. Again, the engine's sitting just a hair higher, which gives us our 1.4 degrees of angle on the U-joints. And you can see over here, that's where I made my trim, so you can see where my initial line was, and just scooted the rear of the engine over a little bit to achieve where I wanted it. And I'll go ahead and kill the lights one more time for you guys, so that way we can see how centered up it is. With the lights off, we're going to find what we would expect to find up here. We have our laser lines centered down the pump, centered through the U-joints of the drive shaft, centered up on this center hole of the China rail up here on the top of the block, all the way down through the valley, and centered up on this front hole on the front China rail, also centered up on the snout of the front of the crankshaft. So we now know that our block is in line with the pump shaft and parallel to the pump shaft, exactly where we want it. So here's my plan of attack to get these feet mounted up. I'm going to go ahead and mount them to the rails first, so I'm going to hold them flush up to the engine plates. I'm going to use a transfer punch. Go ahead, put it through here, mark this hole, get it drilled and bolted in. I'll have these centered so I have the same overhang side to side. I'm going to do that to all 4 feet and get them mounted where I want before I mark the holes going through the plates and get those bolted in. Again, we're going to leave those business cards in there because that gives me the U-joint angle that I want. And that's also going to keep those plates just a skosh above the height of the rail. So I'm going to go ahead, get all these things marked, get them all drilled out, get it bolted in. Now once I'm done bolting everything in, I will confirm all my angles, make sure nothing moved. And then at that point, we're going to have to address all these cuts I made on these plates. We need to dress those up, doll them up a little bit, and make them look nice. But first, it's time to get this mounted. Now since these engine plates have a 4-degree decline in them, it actually was tight to get the drill in to keep it 90 degrees of these plates without hitting the rail. So I decided it would be easier just to pop them out and drill the holes here on the bench. Why I have them on the bench, I kind of seized the opportunity where we can go ahead and address these cuts where I clearanced everything because I think that's ugly. It's functional. It worked for us to get everything fit in. But now you can see that I went ahead and just gave everything a radius. So it's just going to come off, have a radius, angle down, meet that other radius, and angle in on the front plate. The rear plate, much easier. I just basically drew a straight line across all the way where the 2 flats are, and we're just going to cut these 2 ears off, radius them into this curve here for the flywheel. So we're going to go ahead, take these to the bandsaw, make these last cuts on it, clean everything up, and then we're going to go ahead, get them back on the engine. This time I will throw the flywheel cover on, and we'll get it reinstalled for the final mock-up now that all of our holes are drilled. Alright, here we are. Now we got the plates cut, the rear one, that was super easy, not really much to talk about there. Now on the front cut, I actually changed my mind. So I originally had this radius here, did a diagonal line to the second radius, and I kind of got to looking at it, didn't like it. So I brought this other radius in till they intersected and cut it. And I was much happier with that, and it came out quite nice and kept plenty of meat and material here. Looks good and looks intentional, so happy with that. Now that the engine is in and it's on its own weight, let's do one last double check of our angles. So again, we're at 3.9, so that's essentially the 4 degrees of crankshaft plane that we wanted, which should match approximately what the pump shaft was set at and the intake, and that's at 4 degrees right now. So we were targeting 1.5 degree of U-joint angle, so with a 4 degree baseline, we should be at about 5.5. And there we are at 5.3. Depending where I had it, it's at 5.4, 5.6, 5.5. There you go, 5.4. So you guys can see this digital gauge. If you're really trying to chase the fine details, it'll just run you in circles. It'll drive you mad. It moves around a little bit, but you can see that we had the 3.9, the 4 degrees on the pump, and with the 5.4 on the U-joints, that gives me 1.5 degrees of the U-joint angle, which is what we were targeting. So there is something worth talking about that happened to me that kind of had me chasing my tail a little bit. And that is, I had the drive shaft cover off when I did all the angles and mock-ups, and then I installed the drive shaft cover, particularly the bottom cover, and I just happened to recheck angles, and I was missing 0.5 degree angle. And I started scratching my head wondering, like, what's going on? I know I was pretty precise when I drilled the plates. Everything was set in there. And I kind of just started monkeying with it and tinkering around. And eventually I just kind of got lucky stumbled across it. I took the rear drive shaft cover off and my half degree came back. So at one point I had that cover on, I was getting 5 degrees, 4.8. I took the cover off and I was back to 5.3, 5.4. So the best that I can figure is that cover was pressing up on this bearing cap of the pump and was actually pulling the back of the engine down, probably doing some flexing on this flywheel cover and then into the main plate. So I just ended up taking a 2x4 and a big hammer and hitting this plate down on either side to get it off of this pump support, and I got my half a degree back. So I would have never guessed that would have made a difference. I'm glad that I checked and found it. It did make a difference. Easy to overcome. And I'll show you guys right now also that we got the upper half of the cover. Once you go ahead and set that on there, lines up very nice and it doesn't interfere at all and looks really clean. So one thing worth mentioning, guys, is the way I installed this kit. It was a bit out of sequence from what most people do, and I did that on purpose because that's how I felt I was going to achieve the aesthetic look I want and the accuracy that I wanted. I know that I took the long way. I was okay with that, and that's a choice I made because I wanted the final product to look a certain way. Mainly where the rails sit on the height of the stringers, so I created a lot of extra work for myself having to raise those up and trim the plates. I also created work for myself by having to trim the width of the plates because I ordered them so far in advance. But again, that's not a big deal and it's all part of this. Easy to overcome. And for me, what really is important when you install these engines, no matter the sequence of the rails and the plates, is your drive shaft angles. Now, speaking of the U-joint and drive shaft angles, I see a lot of people have different recommendations on this. My personal preference is I'm a big believer that the plane of the crankshaft and the plane of the pump shaft need to be on the same angle, with the engine a little higher or lower to create your degree that you're looking for in the U-joints. I was targeting 1.5 degrees, and that's because most manufacturers recommend anywhere in between 1 and 3 degrees on your U-joint angle. That's why I targeted right bullseye dead in the center at 1.5 degrees. It gave me a good buffer either way if I missed the mark just a little bit. So the last thing that we really need to do to consider this install finished is I would need to pull the plates back off. I need to sand down, smooth out all the edges, break the edges for everywhere that I cut on it and get them repolished. But I am going to go ahead and hold off on that because we still have a lot more mock-up to do. You never know. I might have to make more cuts. I might accidentally drag a wrench across something. So that's really going to be the last thing that I handle on this boat. I'm going to work on getting everything mocked up. Then I'm going to take everything apart, pull all my protection, do all my final polishing, all my final touch-ups, then get the boat back on the trailer, and then actually do the final assembly when it's on the trailer. Which, doing it in that order, it requires a lot of self-control because just as much as you want to see it, I want to see it. I want to pull all this plastic off. I want to pull all that tape off, and I want to see what this looks like. But I just got to hold out because I know that I'm jeopardizing my final product by sneaking that little peek now. So we're just going to have to wait until, well, it's all put back together to see what this really is going to come out looking like. Alright guys, it really feels like I'm starting to crawl out of the trenches on this project. Really starting to see quick visual improvements with not such a time gap in between. You know, now that I'm finally done with all that fiberglass and gel coat work, really starting to pick up some speed. I mean, it's springtime now, so I'm really hustling to get this thing on the water this summer, although it's a fine line because I don't want to cut my attention to detail to hurry up and get it on the water. But anyways, guys, stay tuned to the channel. Plenty more jet boat coming. For those of you that have subscribed, been liking the videos and commenting, as always, I greatly appreciate it. If you're new to the channel, please subscribe. Got a lot more great content coming your way. As always, guys, thanks for watching. We'll see you on the next video.